What comes to your mind when you hear Pluto? Ice? Controversy? While Pluto is known for the two things mentioned here, the celestial body is much more than cold temperatures and arguments about its true nature. And this is why scientists studying this distant space object continue to be amazed by the fascinating discoveries they find. What insane new discoveries have scientists discovered from new images taken from Pluto? What does Pluto tell us about the solar system and the origin of Pluto? Join us as we dive into what new images taken of Pluto shockingly reveal. The story of Pluto is that of demotion and loss of cosmic prestige. This space object once had the status of a planet, but later got demoted to planetoid. What really happened to Pluto? Pluto is unique in many fascinating ways. One of them is how it got its name, from an 11-year-old schoolgirl in England named Venetia Burney. The Lowell Observatory discovered Pluto, earning it the right to name the new object. However, it received over 1,000 suggestions from all over the world, including Pluto from Burney. She was fascinated with classical mythology as well as astronomy and thought the name for the god of the underworld was appropriate for such a presumably dark and cold world. She mentioned it in a conversation with her grandfather, Falconer Maydan, a former librarian at the University of Oxford's Bodleian Library. Maydan passed the name to Professor Herbert Hall Turner, who then cabled it to colleagues in the United States. Pluto officially became Pluto on March 24, 1930. The name was announced on May 1, 1930, and Venetia received £5 as compensation for her effort. Interestingly, the name Pluto honors Percival Lowell, who founded the Lowell Observatory, because the first two letters are his initials. So who discovered Pluto? That achievement is credited to Clyde Tombaugh, a 23-year-old Kansan who just got employed at the Lowell Observatory, although he got assistance from other scientists. American astronomer Percival Lowell was the first to suspect Pluto's existence in 1905 from odd deviations he observed in the orbits of Neptune and Uranus, implying that another world's gravity was tugging at these two planets from beyond. Lowell predicted the mystery planet's location in 1915, but died without finding it. Pluto was finally discovered in 1930 by Tombaugh at the Lowell Observatory, based on predictions by Lowell and other astronomers. Pluto is one of the largest known objects in the Kuiper Belt, a shadowy zone beyond the orbit of Neptune, containing hundreds of thousands of rocky, icy bodies, each larger than 62 miles or 100 kilometers across, along with 1 trillion or more comets. A recent photo analysis revealed a rough patch on Pluto that is unlike anything else on the small world or in our cosmic vicinity. This lumpy region is home to a smattering of unusually enormous ice volcanoes unlike anything else we've ever seen in the solar system. The location is southwest of the Sputnik Planitia ice sheet, covering 621 miles 1,000 kilometers of the ancient impact basin. It mostly consists of lumpy water ice and is covered in volcanic domes. Wright Mons and Piccard Mons are two of the largest. Piccard Mons is around 22,965 feet 7 kilometers high and 139 miles 225 kilometers wide, whereas Wright Mons is roughly 13,123 to 16,404 feet 4 to 5 kilometers tall and spans 93 miles 150 kilometers. The Mauna Loa volcano in Hawaii is one of the largest volcanoes on Earth, and Wright Mons is thought to be comparable in size. Some of the domes seen in the photos combine to form even larger mountains, but what may have caused them to exist? It all boils down to ice volcanoes. Ice volcanoes have been discovered in other parts of the solar system. They produce a new landscape by moving material from the subsurface to the surface. When the water reached the freezing temperatures of Pluto's surface, it swiftly turned to ice. Pluto's snow-covered mountains look like they belong on Earth, but they are in fact completely different from our own planet. It's hard to compare the appearance of these features to any other volcanoes in the solar system, be it icy or rocky. They started out as mountains, but there is no caldera at the top, and they are covered in big bumps. Pluto is very far from Earth, so understandably, little was known about its size or surface conditions until 2015. Pluto has a diameter of 1,473 miles, or 2,370 kilometers, less than 1/5 the diameter of Earth, and only about 2/3 as wide as Earth's moon. So Pluto is almost half the width of the United States. Pluto's surface is one of the coldest places in the solar system at roughly minus 387 degrees Fahrenheit or minus 232 degrees Celsius. Also, when scientists compared pictures of Pluto taken by the Hubble Space Telescope, they realized that the dwarf planet had apparently grown redder over time. They suggest this change was apparently due to seasonal changes. Pluto has a highly elliptical orbit that takes it more than 49 times as far from the Sun as Earth. Due to the eccentricity of its orbit, Pluto's distance from the Sun varies significantly. The dwarf planet gets closer to the Sun than Neptune is for 20 years out of Pluto's orbit, which is equivalent to 248 Earth years. As a result of that orbit, after 20 years as the 8th planet, counting from Mercury, in 1999 Pluto crossed Neptune's orbit to become the farthest planet, in quotes, from the Sun. At the closest approach, or perihelion, Pluto is 2.75 billion miles from the Sun and 4.54 billion miles away at the farthest of aphelion. Pluto is blessed with 5 moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is the closest to Pluto, and Hydra is the most distant. Pluto has a very large moon, nearly half the dwarf planet's own size. This moon was dubbed Charon after the mythological demon who ferried souls to the underworld in Greek mythology. Because Charon and Pluto are so similar in size, their orbit is unlike that of most planets and their moons. Both Pluto and Charon orbit a point in space that lies between them, similar to the orbits of binary star systems. So scientists refer to Pluto and Charon as a double dwarf planet, double planet, or binary system. Pluto and Charon are just 12,200 miles, or 19,640 kilometers apart, less than the distance by flight between London and Sydney. The Earth and the Moon are separated by 384,000 kilometers in comparison. Charon completes an orbit around Pluto in 6.4 Earth days, and one Pluto rotation, that is a Pluto day, is similarly 6.4 Earth days. This is because Charon hovers over the same spot on Pluto's surface, and the same side of Charon always faces Pluto, a phenomenon known as tidal locking. Pluto is known for its ice, but what happens to Pluto if it gets close enough to the Sun? If it did ever get close enough to the Sun, much of the surface ice would eventually thaw, and its atmospheric layers would be at their thinnest, lacking much of its carbon monoxide ice, but mostly retaining its nitrogen and a little bit of methane. At that point, scientists might consider Pluto to be in its most habitable form. Although we have no idea what to do about its low gravity, which is about 1/20th of the Earth's. Hence, its atmosphere appears much denser and higher than Earth's, and the further it strays away from the Sun, the denser it becomes as the atmosphere freezes until it phases out of view. When considered at its thinnest, scientists have surmised that it restricts the flow of fluids. One proof of this is provided by the New Horizons in an image of a frozen lake in the Tombau Regio. They also saw what looked like water channels. We join them in thinking about the possibility of the planet having an atmosphere 40 times denser than the red planet, talking about Mars, of course. There were also observations of certain cloud forms in the atmosphere. The clouds were formed at low altitude with technically the same sizes, but the major components of these clouds are thought to include acetylene, ethane, and hydrogen cyanide. So why did Pluto lose its status as a planet? When Tombaugh discovered Pluto, textbooks were immediately updated to include this 9th member in the club. However, over the ensuing decades, astronomers began to question whether Pluto might simply be the first of a population of small icy bodies beyond the orbit of Neptune. This region would become known as the Kuiper Belt, but it was not until 1992 that the first occupant of the region was discovered. The candidate Kuiper Belt object KBO 1992 QBI was detected by David Dewitt and colleagues using a ground-based 2.24-meter telescope at Mauna Kea. The discovery of the first KBO escalated the existing debate on the planethood of Pluto. In 2000, the Hayden Planetarium in New York became a focus of controversy when it unveiled an exhibit featuring only 8 planets. The planetarium's director is Neil deGrasse Tyson, everybody's favorite astronomer. Pluto's days as a planet became numbered with the discoveries of Kuiper Belt objects with masses roughly comparable to Pluto, such as Quaoar, Sedna, and Eris. Eris in particular appeared to be larger than Pluto, making some astronomers honor it with the informal title of the solar system's 10th planet. Drama ensued when the International Astronomical Union set up a committee to define just what makes a planet a planet. Incredibly, the first effort of the committee would have increased the number of planets in the solar system to 12 because Pluto and its moon Charon were recognized as twin planets, and Ceres and Eris were granted entry to the exclusive club, but the idea met with opposition. Eventually, the committee set 3 criteria that a planet must meet, and this dealt a huge blow to Pluto's standing as a planet. The conditions were: 1. A planet must orbit the Sun. 2. A planet must have sufficient mass for its self-gravity to overcome rigid body forces and assume a round shape. And 3. A planet must have cleared the neighborhood around its orbit. Pluto met the first 2 of these criteria, but the last one proved thorny. Clearing the neighborhood means that the planet is either vacuumed up or expelled other large objects in its vicinity of space. So basically, it has attained gravitational dominance. Unfortunately for Pluto, it shares its orbital neighborhood with other icy Kuiper Belt objects, so the resolution effectively stripped the distant world of a planetary designation it had held for some 76 years. It was immediately demoted to the status of dwarf planet. But of course, this move presents some rather interesting cosmic conundrums. For instance, the Earth shares its orbital turf with more than 12,000 asteroids. The same with Jupiter and other planets. Does that make the Earth unplanetary? To rub it in the face of Pluto, the international scientific community recognizes Pluto's historic downgrade with a holiday called Pluto Demoted Day every August 24th. Worse still, the American Dialect Society voted Plutoed as the word of the year, with the meaning being to demote or devalue someone or something. Let's talk more about the ice on Pluto. For decades, scientists believed that Pluto's stony core lacked the internal energy necessary to stoke volcanoes. They believed that several eruptions would have been required to form the area. Additionally, the lack of impact craters in the area, which can be observed across Pluto's surface, shows that the ice volcanoes were active very recently and that Pluto's interior has more residual heat than expected, implying that our understanding of planetary systems is incomplete. As far as geological timescales go, the ice volcanoes may have been active as recently as 100 million or 200 million years ago. Observing Pluto's ice volcano would be an experience unlike anything you've ever seen before. On this dwarf planet, instead of erupting gases and molten rock, the cryovolcanoes on this dwarf planet expel massive amounts of ice, most likely frozen water. While flowing out of its volcanic vent onto Pluto's surface, the frozen material would most likely be a slushy mix of ice and water, or more like toothpaste. The explanation for this is that liquid water cannot last long on Pluto's surface due to its extreme temperature. In any event, the flow of material created the gigantic domes that we see today and the bumpy topography that can be observed across this region. The team working on New Horizons was only able to observe the region for about a day as it flew over this region. Therefore, they were unable to observe any present ice volcano activity. In theory, the ice volcanoes could still be active at this time. They could be like Earth's dormant volcanoes, which become active again after a period of inactivity. How did Pluto form? This is quite interesting and takes us back to the formation of the solar system itself. Approximately 4.6 billion years ago, the solar system was a cloud of dust and gas known as a solar nebula. What happened next was that gravity collapsed the material in on itself when it began to spin. The sun then formed the center of the nebula. However, not all the materials went into the formation of the sun, and the remaining pieces began to aggregate. Small particles started pulling together thanks to the force of gravity and formed larger particles. The lighter particles got swept away by solar, leaving only heavy rocky materials to create smaller terrestrial worlds. But as we move further away from the sun, the solar winds had less impact on lighter elements, and they began to coalesce into gas giants. This is how asteroids, comets, planets, and moons were born. Scientists say Pluto's rocky core was the first to form under this scenario. From there, gases and ices would have been pulled in gravitationally, with the core growing larger and larger. But like the other dwarf planets, Pluto failed to gather enough mass to reach the classification as a full-scale planet. Some scientists once called Pluto a Neptune reject. The early days of the solar system were really chaotic, with planets, dwarf planets, and asteroids scattered all over the place. However, order started to appear as the planets traveled through their paths. Their significant mass gave them a great deal of gravitational power, allowing them to change the orbits of smaller bodies. Some of the smaller bodies were catapulted into the sun, while others were cast out by the solar system completely. It was Pluto's bizarre orbit that made many astronomers conclude that it was once orbiting Neptune before being kicked out. However, Pluto's orbit is such that it can never collide with the large planet, meaning that it could not have once been part of its system. There is something else scientists have come to conclude from the ice of Pluto. In addition, some scientists believe that Pluto has a liquid ocean beneath its ice cover that is around 249 miles thick. According to this theory, Pluto's moon Charon developed later in the dwarf planet's existence as radioactive materials decayed near the rocky core. A subsurface ocean could have formed as a result of this heat. Contrary to popular belief, however, the data from New Horizons suggests otherwise. According to new research based on that data, Pluto may have been formed in a heated formation scenario. Those extensional fractures detected by New Horizons in Pluto's ice surface could be caused by the gradual freezing of the liquid ocean over time. These ice volcanoes may indicate that Pluto's once prominent subsurface ocean is still present and that liquid water may be present within a short distance of the planet's surface. In conjunction with previous findings of Pluto's interior being warmer than previously thought, these new findings raise intriguing questions about Pluto's potential habitability. However, other scientists claim that any organism attempting to thrive there will face numerous difficulties. Even if the volcanism is episodic and hence the availability of heat and water is intermittent, life would still require a constant source of nutrients. Sending an orbiter to Pluto to investigate its fascinating subsurface would be necessary. We may utilize ice-penetrating radar on a future expedition to see directly inside Pluto and observe what the volcanic plumbing looks like. Scientists are set to learn more about Pluto thanks to the new James Webb Space Telescope. Even though its main job is looking into the billions of years of the universe's history and searching for exoplanets, that is, planets outside the solar system, it can also be trained on planets within the solar system. NASA used Jupiter during the testing of the JWST, and even though the images captured of the Jovian planet didn't get the full treatment or image processing, it is still stunning the amount of details captured. A view from the NIRCam instrument's short wavelength filter shows distinct bands that encircle the planet as well as the Great Red Spot, a storm big enough to swallow the Earth. The iconic spot appears white in this image because of the way Webb's infrared image was processed. Clearly visible at the left is Europa, a moon with a probable ocean below its thick icy crust and the target of NASA's forthcoming Europa Clipper mission. What's more, Europa's shadow can be seen to the left of the Great Red Spot. Other visible Jupiter moons include Thebe and Metis. Scientists were excited by these images because they prove that JWST could see the satellites and rings near bright solar system objects such as Jupiter, Saturn, and Mars. In fact, scientists are waiting to use the JWST to confirm if we can see plumes of material spewing out of moons like Europa and Saturn's moon Enceladus. The powerful telescope may be able to see the signatures of plumes depositing material on the surface of Europa. So if you're a fan of Pluto, you're allowed to be excited by what the JWST will discover on the dwarf planet. However, before that, New Horizons has been instrumental in expanding our knowledge of icy Pluto. The spacecraft also revealed the unusual mechanics of Pluto's beating heart-shaped glacier, which is about the size of Texas and even helps generate the planet's wind. The heart-shaped feature is known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto in 1930. Nitrogen ice dominates this part of the dwarf planet, which is home to the deep basin known as Sputnik Planitia due to its elevation of 1.9 miles below the planet's surface. The basin is the left lobe of the heart, with nitrogen glaciers and highlands on the right side. Pluto's frozen nitrogen core thaws enough to turn into vapor throughout the day. It begins to freeze over again at night. Scientists refer to this as Pluto's heartbeat, which regulates nitrogen wind circulation in the planet's atmosphere. The wind is created when Pluto's frozen heart beats. Because expansion would occur throughout Pluto's history, this protracted, progressive freeze of the subterranean ocean could also explain the variety of characteristics on the dwarf planet's surface. Pockmarked surfaces were also found on Pluto and Charon in photos taken by New Horizons. Large craters dot the landscape. It appears from the craters that Pluto and Charon were struck by small Kuiper Belt objects less than 100 kilometers in size. The fact that no impact craters smaller than 13 kilometers in diameter were identified suggests there are fewer Kuiper Belt objects smaller than 2 kilometers that astronomers had projected based on what scientists know about impact crater formation. This lends credence to the theory that Kuiper Belt objects may not be chunks of space rock generated by collisions, but rather unbroken leftovers from the formation of the solar system billions of years ago. Also, the dunes on Pluto are only one of the planet's many surprises. On Pluto, the dunes are not composed of sand like that of Earth, but of solid methane ice grains that are molded by the wind. Dunes are more common than you might expect in our solar system. They exist solely on Earth, Mars, Venus, Saturn's moon Titan, and comet 67P. Due to the fact that these dunes are mostly undisturbed on Pluto's frozen crust, it's likely that they were produced within the last 500,000 years, or perhaps less recently. Pluto creates an age-old dilemma in this way. Polygonal shapes and features on the dwarf planet's surface indicate that it's a young and active geological system. The surface is only a few thousand years old despite the dwarf planet's 4.5 billion-year-old age overall. A thermal convective overturning of the ice is most likely the cause of this action. These are only a few of the discoveries made possible by New Horizons data, and more will be found in the future as scientists sort through the massive amount of data collected during the flyby. These are just a few of the discoveries of Pluto. More discoveries will be uncovered in the future as scientists examine the dwarf planet. Let us know what you think of the dwarf planet discoveries in the comments section below.